According to quantum mechanics, all particles in the universe are described by what we call a wave function. Properties such as position and momentum do not have defined values until they're observed. The probability of each possible observation is determined by the wave function. Suppose we have a particle moving freely through space in one dimension. Its wave function may look as shown. The probability of the particle being at a particular position is given by the square of the amplitude of the wave function at that location. Now let's consider a particle that's moving in one dimension but is trapped inside a box. Its wave function may look as shown. At each point in space and time, all wave functions are described by a complex number. All complex numbers have a real component and an imaginary component. A particle with a higher energy will have a wave function that rotates with a higher frequency, and it will look like this. The wave function can also be in a combination of this waveform and the previous one. We say that this wave function is in a superposition of the two wave functions we saw earlier. Since this waveform is a combination of two different wave functions with different energy levels, the energy of this particle is uncertain. When we measure the energy, we say that the wave function collapses into one of the two original wave functions. The wave function's frequency determines the particle's energy. The momentum of the particle is determined by the wave function's wavelength. A longer wavelength implies a smaller momentum.